All right, in this video, I'm going to do a few more example on how to find the equation of a plane. Okay, so this is a section 2.5. So example number 4. Find the equation of the plane. So passing through a point 322 and perpendicular to the line. Okay, so you have a plane. That plane passes through a point 3, 2, and 2. So I'll just give you hints and then probably you can finish this problem, okay? And this plane is perpendicular to the line. So there is a line here. Line goes maybe like let's see, I don't know, line goes like that. Let's see. Maybe I didn't do a good job here drawing. Let's see, the line goes like that. That's a perpendicular, okay? Perpendicular to the line. So your plane is perpendicular to the line, okay? So that means if you want to find the equation of a plane, you need a point. So equation of a plane. If you want to find the equation of a plane, you need a point on the plane, and 2 is a vector or normal vector or perpendicular vector, right? Perpendicular vector. And then in the last time we said that n is the vector. Do you remember that? And so a, b, c was the vector. N vector, right? You need that one, right? So since this line is perpendicular to the plane. So what is the direction of this line? Direction, right? So direction, that means you see that, like, I don't know, you guys remember this one? 4, and then there's over 1, that's a 1, and -3 is the vector, right? That's a perpendicular vector to the plane. That's a direction of a line, direction of the line, right? The direction vector of the line. This will give you the direction vector, right? That's the line anyway. So that's the vector is this. So you have a direction vector which is perpendicular. This is equal to n vector now, right? I mean, it's not a unit vector. You don't need a unit vector. This vector is perpendicular to the plane, and then you have 3, right? So that's, you have a point. So you can figure out by finding the equation of, like the setup is, I don't know, because this is a 1 point. So it's like another point is, let's say x, y, z is another point on the plane, like x, y, z, right? Then what do you do? X minus 3, y minus 2, and z minus 2. That's a vector dot with 4, 1, and -3, right? The dot product must be 0 because they're perpendicular, and you can figure out the equation of the plane, right? To that one, if you have a question, let me know. Let me move on to next problem. Here, find the equation of a plane passing through the points. So you have a plane, you have 3 points, right? So let's see, one is 3, -1, and 2. All right, that's 1 point. Another point is 2, 1, and 5. That's other point. And maybe there's other point is 1, -2, and -2. All right. So if you have 3 points on the plane, find the equation of the plane, right? So remember that I have to have a 1 point. I have 3 points, so that's more than enough. But I need a vector which is perpendicular to this one, right? So let's say if the vector goes like that, maybe somewhere here, and then that, I need a vector like that, okay? how do I find this vector which is perpendicular to the plane? I don't know if you remember from your cross product, I think you can see that if I create a vector here connecting this one, it doesn't matter which one you go, you connect this one, find this vector, find this vector. Let's say this is A vector, this is B vector. Okay, so if I do A cross B, what are you gonna get? This A cross B, you're gonna get a vector perpendicular to both vector A and vector B and vector B. All right, do you remember from your cross product? So that's the vector which is perpendicular to the plane, right? And this is the that's the vector perpendicular perpendicular to the plane. Sorry. Okay. So we got the vector perpendicular to the plane, which is whatever comes from here, this one. And then you can choose any point and you can find the equation of the line. Equation of the plane, plane. All right, hope that helps. All right, next one, let me do here. Find the set of parametric equation of the line. So I need to write down equation of a line in a parametric equation form, okay? So that passes through a point. So there's like a line that passes through a point. Let's see, that point is somewhere, I don't know, a -4, 5, and 2. That's the point, right? I mean, if you draw in a xy axis, a z, there's a z, this is x, this is y. The -4 is going to go -4 somewhere here, and then 5 is going to go this 5 and 2 up like that. All right, so that's the point, right? Sorry, you don't need a vector there. That's the point. Okay. Let me choose the color. So that is the point. That's the point you talk about. Okay. So you need to find the equation of a line that passes through the point and the perpendicular to the plane. So so this, like, there is a plane here. Let's see, I don't know, can I draw this plane? Let's see, I want to do this, I want to do that. There is a plane here, it goes here. Let me just, I don't know if I can erase a little bit. Okay, let me change this. Okay, let me go back here. So this line goes like that and coming from here, right? So that's a perpendicular here. So again, equation of the, I need to find the equation of a line, and there's a point on the line. Okay, there's a point on the line. Sorry, my bad headphone. Second, let's turn it off. There is a point, and then there is a plane which is perpendicular to the line, right? So that's so what do I need? I need a direction of the line, right? I have a point, I need the direction of the line to find the equation of a line. All right, so let's see, what is the direction of the line gonna be? So that is the, if you look at the plane, if you compare with the if you look at the plane, there's a -1 comes from here, 2 comes from here, and 1 comes. That's the perpendicular. This vector is perpendicular to the plane. All right, to the plane. So that means, but that is the direction, which is the direction of the line, what we needed. Does it make sense? Because that's the, remember that, let me change the red. So this is the line, and then that is the vector n vector, which is the perpendicular to the plane, right? And which is what we needed. So this is the vector perpendicular to the plane, which is the direction of the line. I have a point. Now you can figure out what is the equation of the line is. All right. Hope that helps. All right, I'm going to come to next video to do the rest of the problem.